Hi everyone, welcome to Deep Learning Talks. So, the most common and the most favorite topic for most engineers. What exactly are large language models? We are going to clear some jargons today and we're going to talk about a lot of technical terms that are used very casually in the industry. So, what is a large language model? And is ChatGPT a large language model? Is Gemini a large language model? So, all of these foundational models or frontier language models are also known as large language models. And before we move on to large language models, I would also like to define what are these frontier AI companies or foundational model companies. There are two broad sets of AI companies in general. One is the foundational AI companies or the frontier language model development companies like Gemini being owned by Google, ChatGPT being owned by OpenAI. Other companies, other group of companies that are so-called AI companies are the applicative AI companies who are building another layer on, so who are building on top of these foundational language models. So they are also known as applicative AI companies. So any foundational AI company would be spending billions of dollars in training AI models, billions of dollars in training frontier language models or large language models. So before we define a large language model, we should also know that they are nothing but a transformer. Internally, they are only a neural network. And what makes them large is a lot of things like data, compute, and parameters. We will talk about each of these in the future upcoming videos, but you have to build a mental model to understand what is a large language model and without being intimidated from it. So if you come from a mathematical background, if you come from a statistical background, uh, it's going to be very easy for you to digest that AI is not magic. We are using a neural network everywhere, and especially in large language models, just to approximate the next token. We don't really have any creative engine that is sitting behind and that can simulate a neurological or a biological brain. So AI is, when we talk about neurons, we don't directly want to represent biological neurons. AI, or especially the large language models, are nothing but neural networks or function approximators. They help us predict a sentence. More nuanced, they help us predict the next word. More depth, they help us predict the next token. More depth, they help us predict the probability of the next token among the probabilities of a lot of tokens. So it's like they generate, or they sample probability for a lot of tokens. Let's call them token list of j, and then we sample from that probability distribution the next token. If I were to define it with respect to probability, it's like I am predicting the probability of a token xt given token x1, x2, x3, x4, and so on xt minus 1. It's like I am predicting the future tokens in a left to right sequence. That's why the transformers behind these large language models, or the neural network behind these large language models, are also supposed to go in one direction, which is left to right. And they predict the future tokens. They don't predict the future, but they predict the future tokens. If they predict it in an auto-regressive way, which is in a repetitive way, then we call them a generative model, that they are able to generate a lot of text. They are able to generate a lot of text because we are putting them in a loop so that they can predict the next token, and then the next token acts as an input which helps in predicting the other tokens, right? So this is known as auto-regressive generation of tokens. When we enforce the conversational behavior in them, then it becomes a conversational AI, or a large language model, or a chat GPT, or a Gemini, right? So why do we also call them foundational model? This is also a key jargon that we keep on listening. It is foundational because I mean, foundational, it's not a mathematical definition, but it's a generic abstract keyword that we use because it acts like a generic brain, not the biological brain, but it acts like a generic brain trained on the internet. We had a lot of internet data, or we had, let's say, all of the internet data up to a certain timestamp, and we fed it to a neural network. I use neural network and transformers casually here because I'm representing transformer also as a neural network, right? So we fed a lot of internet scale data or internet data to a neural network and enforced it or trained it to predict the next token based on what they learned from the internet. So can we say we are essentially simulating tokens on the internet? Yes. So they are internet simulators, next token simulators, next token predictors, and when we put them in a loop in an autoregressive way, they become next token predictors. So that we can think about them in like an autocomplete engine. When we make them conversational, when we train them to behave as an agent, right? Then they become conversational AI. Then we call them a chat GPT. Then the GPT becomes the chat GPT, which is exposed as a product, right? So these are all the technical jargons that are hidden behind a large language model. Now, in a separate video, we will talk about why the name large comes into picture. What exactly makes a large language model large, and what is the relevance of the three pillars of a large language model, which is data, compute, and parameters. So let me also clear some boundaries on what are these parameters that we keep on plugging in when we talk about a language model. So any large language model, since it's a neural network, is going to have a lot of parameters. So now that it's a mathematical function, it's an X token predictor function, we know that there is no brain involved in whatever we are doing. It's a simple math function. It has an objective. The objective is to create the next token, or sorry, predict the next token, not create it. And it is trained on the internet data. So since it is trained on the internet data, it is very much foundational in nature. It is not defined to do a specific task. It is not fine tuned or specialized to behave like a lawyer, to behave like a doctor, to behave like a specialized person. That's why we call it a foundational model. Since internet is a decent enough representation of all the knowledge in the world, or let's say most of the knowledge in the world, that's why we call them a foundational model, right? So now, what are parameters? So for people who are coming from a mathematical background, or for people who have heard about a very simple algorithm like linear regression, you might have heard that y equals to mx plus c represents the equation of a line. Since y is equal to mx plus c represents the equation of a line, we call that is acting as an output, x is acting as an input, m and c are the parameters of a line. So m and c are those parameters that just help us defining a line. So they are also the parameters of a linear regression model. Just like linear regression has these two parameters, y is equal to mx plus c, m and c, the first language model had hundreds and thousands of parameters. Then it evolved into multi-million of parameters. That means we had millions of m's and c's. Then we evolved to having billions of m's and c's. And then, we have hundreds of billions of m's and c's, which are nothing but the weights and the biases and so-called parameters. Weights and parameters are used interchangeably of that neural network, right? And we are calling transformer also as a neural network because it essentially is a neural network, right? Transformer will also have a forward pass. It will also have a backward pass, just like any neural network do. Transformer will also have an equation. Transformer will also have an objective function and the parameters and the architecture, just like a neural network does. And since neural network is evolved from a simple model like a perceptron or maybe a logistic regression, transformer can also be broken down into a simple equation, right? So we'll talk about more and more nuance uh, of a large language model in the coming videos, but this video sets the ground straight for understanding and developing mental models around large language models, and disambiguating all the jargons around large language models. Thank you. I hope you liked it.